All right, welcome to Unit 6, Lesson 19, Division with and without remainders. Let's find quotients and remainders using an algorithm that uses partial quotients. Okay, raise your hand. What is a quotient? Quinn?
The answer of a division problem.
The answer of a division problem. So if I have, I don't know, 9 divided by 3, what is the answer to that? 3. Okay, this 3 on top of the house is your quotient. Okay, what do we call the 9? Dividend. Good job, Brayden. The 9 is in the house, but we call him the dividend. Okay? What is the 3 called? Divisor. It's knocking on the door. This is not my best handwriting. Okay. Okay. All right. Notice and wonder is our warm-up. What page is it? Did anybody figure this out yet? 84. So you're going to take a look at these problems, jot down a few notes. What do you notice? What do you wonder? And then we'll check. All right, let's share. What do you notice? What do you wonder? Hey, Mason.
I noticed that they're all backwards.
What do you mean backwards?
Like the
Business. Okay, Emma, what do you notice? Wonder.
They're all 100, 200, 300, 400, 500, 600, the answer.
So are they counting by 100?
Yes.
Okay, count by 100. Oh, Mason! I knew I was doing something and the phone rang.
like the answer at the very end when they're usually at the end.
The answers are usually over on the right side, right?
Yes.
They wrote them backwards. How nice of them. Chase.
That if it's like it starts at 33 and then it goes 66 and then it goes 100 and then 133 and then 166 and then 200.
Isn't that interesting? Okay, Vivian, what'd you notice?
It's all multiplied by 3.
They're all multiplying by 3. So our factor, they all have 3 as a factor, don't they? Okay, Hadley.
Some of them are like adding stuff onto it to make it another number.
But, yeah, some of them, but not all of them, right? Yeah, so we've got plus 1, plus 2, nothing. Plus 1, plus 2, nothing. Madeline?
The 166 times 3 is it's different on our book. It says 1 plus 1 instead. Yeah. Yeah, it does. I was just gonna say. What is it?
So,
It says plus 2 instead of plus 3.
okay, hold on. I got to do some quick math. We're adding 2. I feel like your book is wrong.
Yeah, the book is wrong.
The book is wrong because if you have plus 1, you're not going to get 500, are you?
You're gonna get 499.
Should I email them?
Yes.
Yes. Okay. I will do that. All right. Anything else? I think we covered it. Aaron.
The adding goes in a pattern. It goes 1, 2, nothing, 1, 2,
Nothing. So lots of patterns, huh? Yeah. And they all equal nice, even numbers, don't they? Very interesting. Okay, mark your spot in your book and close it so we can, we're moving on, so we can do our launch. Okay, Jada is at it again. She was playing with base 10 blocks the other day. Now she's come up with her own algorithm. Jada used partial quotients to find out how many groups of 7 are in 389. I see her division problem right here. Do you guys? Okay. You're going to analyze her steps. So if we look at number 1, you're going to look at the 3 numbers. Look at, she stacked some numbers. Do you guys see how she stacked those numbers? Okay. You're going to see if you can figure out what they represent. Then you're going to look at the 3 subtractions right here, and you're going to see if you can figure out what those represent. And then you're going to see if you can think of another way to decompose 389 to divide by 7. So after you examine it, you're going to come up with a similar method to hers all by yourself. Let's see if there's a number 2. There is a number 2. Then you're going to answer a question. And then, oh, there's a 3 and a 4. Okay, well, this is interesting. Number 3, use an algorithm. Is digit by digit an algorithm?
Yes.
Okay, can you use it?
Yes.
Okay, so you have 4 questions. Yes, Kate.
If you go back to the other one, I think it said that uses partial quotient to find
Oh. Okay, you did. You read the whole question. You're right. Okay, number 3, give it a go. But you know what? Like I told you guys, you're doing CMAS tomorrow. You need to know how to divide. I would say try to come up with partial quotients. You might be able to, right? If you can't, can you do the digit by digit?
Yeah.
But give it a try first. This is like really good for your brain, Brayden.
I'd rather do base 10 blocks.
Yeah, me too.
Not me.
All right, guys. I want you to follow along with me. So, Jerica taught me Big 7 a minute ago. If you know Big 7 is partial quotients. Okay. Where did Miles go? He was partners with Maya. Where did she just go?
I think Maya's
Bathroom.
Maya.
Okay.
Yeah, mine's in the back.
And Maya's in the back. Okay. All right. So we're going to dissect this thing. So first of all, look at the 3 numbers above 389. What did those 3 numbers represent? What did we figure out? Riker.
It represent 280, 49, and 56.
They represent what?
280, 49, and 56.
Okay, I see what you're saying. Okay, so what do you mean 280? How do they represent 280? Riker.
Because it would be 7 times 4, which is 28, but they're doing, they have to do it 38, so they would add 0.
Okay, so if we have 40 here, so they did 7 times 40 to get 280. Okay, how did they get 49? Hadley.
7 times 7 equals 49.
7 times 7. How did they get 56? Okay,
8 times 7?
7 times 8 or 8 times 7. Okay, then,
Wait, but
that was B. Look at the 3 subtractions below. Isn't that part B?
yeah, that's B.
So what do these 3 numbers represent? Delaney.
If you add them together, you get 55.
So if you add 8 plus 7 plus 40, you're going to get 55. And what is 55?
The quotient.
The quotient, the answer, right? Okay. So, I don't know. So looking at this, you guys, this to me looks like a strategy I know called repeated subtraction. And basically it's the same as Big 7. It's just written differently. So what I'm doing is I'm looking at 7 going into 389. And I'm thinking to myself, and I used to call this a helper problem. 7 times what number gets me close to 389? What number would get me close? Two? What's 7 times 2? That's way too low, isn't it? Okay. What if
84.
You guys are shouting. Okay, what if I cover up the 9? 7 times what number is close to 38?
35.
5. Because 7 times 5 is 35. So if I put a 5, right, I'd get 35. But what would happen if I made it 7 times 50? Is 350 close?
Yes.
So then I would say to myself, okay, well, I could put 50, and I know that's 350, right? And I could subtract. 9 minus 0 is 9. 8 minus 5 is 3. Now, I only have 39 left. 7 times what number is close to 39? 5, right? Because 7 times 5 is, so I would stack a 5, and if I subtract, I get 4. So then I would just add these two and get 55, remainder 4.
Is it the same answer as that one?
It is the same answer, but did I decompose it differently?
Yeah.
Now that is how I would teach partial quotients. Is I would try to come up with these helper problems and then subtract them. Okay? I don't know. Some of you guys might like it, some of you might not. Okay, what were some of our other questions? Is 389 a multiple of 7? Raise your hand. Is it a multiple of 7? Kaylin. Exactly. If we have a remainder, then it can't go in evenly. So our answer would have to be no. Okay, number 3 says use an algorithm that uses partial quotients to find out how many groups of 3 are in 702. So, the problems I saw in your papers all were digit by digit. Did anybody do partial quotients?
We tried.
You tried. Good.
That was our try.
So I'm going to use my strategy, and you're welcome to follow along. So I'm going to think to myself, okay, 3 times what number gets me close to 702? What do you think, Jerica? What are you thinking?
20, 3 times 20.
Sure, we could start with 3 times 20. And 3 times 20 would give us 60.
Yeah.
What could we do to that 20? Hadley. What's 3 times 200?
That's right. 600.
Oh, now we're close, right? So if we think of those multiples, or those benchmark numbers, hundreds and tens, that helps us. So I would say, okay, 3 times 200, we know is 600. If I subtract, now I'm thinking 3 times what number is going to get me close to 102? I think Hadley's figuring it out. What are you thinking?
Maybe like somewhere around like 28, maybe.
So if I did 20, I know I'd get 60. I could do that. We could do that. Or what if we did 20, 30? 3 times 30? We could start counting by tens. Yeah, what do you think, Jerica? What'd you say? Yeah, so if we did 3 times 30, what does that give us? 90. And is that pretty close to 102? Okay, bless you. So, bless you. So then I'd put a 30 up here, and 30 times 3 is 90. I'd subtract, and I have 12. So I'm thinking 3 times what number gets me close to 12? Hint, hint. Okay, 4. It's fine. Stick a 4 up there, right? 12 minus 12, I'm running out of room, is 0. So if I add those, I'd get 234. And that's my answer. Yeah, Riker.
I did 35 times 3 at first, and I got
Too big, right? 105?
yeah. It would be added to 100 to that equals 705.
Oh, yeah, yeah. Yeah, so you could definitely start with a bigger number. Okay, guys, this is just partial quotients, okay? Is this a method that any of you are going to use all the time?
No.
Maybe. You might, but I don't know, probably not. Okay, we just talked about it. All right, now we're going to look at activity 2. Andre and Elena are dividing a big number by 5, 2,316. Before they begin, Andre says, I can already tell that there will be a remainder. How do you guys know? Without doing any calculations, how do you know there's going to be a remainder? Keston.
16 is bigger than 5. I mean, the 6 is bigger than 5.
It ends with a 6, right? Riker.
If I can only 5 getting multiplied and 5 is
Right. So the number has to end with 5 or 0 for 5 to go in evenly. Okay? So now you're going to look at Andre's work and you're going to look at Elena's work, and they have 2 totally different answers. Somebody, or maybe both of them, it looks like both of them made mistakes. So you guys are going to analyze their work, see if you can find each of their mistakes. Then we're going to meet and synthesize. What is activity 3 before I let you go?
It's like that. It's just have to find the answer. It's really easy.
All right. When you are done with activity 2, come show me. All right. So guys, let's take a look. We're going to look at Andre's work right here. Okay. So, first thing I want you guys to tell me, what are the partial quotients? Which numbers up there are partial quotients? Oh, I guess quotients is an answer. Are these the answers?
No.
The partial quotients?
Yeah.
Or would you say that these are?
Those are.
I think those are.
Oh.
Okay, how did he get 2,000? That's what I want to know. What did he multiply? Come join me. You're too far away. Join me. Come closer.
I know.
What did he multiply? It would have to be times 5, right? What did he multiply?
200 times 5. I mean 400.
So to get 2,000, you would have to do 400 times 5, right? Where is the 400? Where's the 400?
Well, I looked at the 40 above, and I just realized that would only be 200, so I just added the extra zero to the 400.
Okay, so do you think you know what his mistake was? What was his mistake, guys?
He forgot to add the zero there.
So did he forget or did he add an extra 0?
Add.
He's got an extra 0 because what he should have done is 5 times 40. And what's 5 times 4? 20 plus 1 0, right? He wrote 2,000. So if he had written 200, then he would have been able to find more numbers, and this 103 would have been much bigger, right? That was his mistake. Okay, for Elena, what was the one mistake she made? What was her mistake?
She forgot to add the remainder, and she forgot to put the remainder even on there. Because she forgot to do the 5 times 3 equals 16 minus 2, that's 15.
So she should have done one more step, right? To get 5 times 3 is 15. And then she would have had the right answer. 1, remainder 1. Okay.